Hi, Sai Krishna. Hello.
Hey sir, how are you?
I'm good, thank you. And Vimlan is also joined. I think his audio is not uh, accessible. Let just check. Hmm. Yeah. So today I'm going to start the Docker and Kubernetes session, and this would be the around 45 hours course, and the webinar is free. So anyone can join on this. Um, You are able to see my full screen slide, right? Can you confirm, Dilip?
Yes, yes.
Okay. Yeah. So Docker and Kubernetes, these are the technologies currently used mostly in the DevOps. They are into very important role during the deployment phase. Applications deployment is broken down into small pieces and it became microservice architecture. Software development is changed a lot, and that life cycle is changed for the software. So it is a when we are working on small pieces, we need containers. So we try to understand what is the containerization using the Docker. Once we made the Docker containers, and then we'll try to understand Kubernetes, that is orchestration too. So this is a overall agenda what we are going to discuss in this demo. But yeah, it's a very high level. I think we may discuss more detail when we come to the course. At the moment, I'll just give you why, what, how. These are the main goals which I'm going to discuss in this session. Okay, so this Docker and Kubernetes course, this is mostly useful for the people who are already into the development phase or who know infrastructure, how it is working for AWS or GCP or some other clouds. And this will give you a very good booster for career growth. Okay, so Docker is a technology. So we are going to learn about this technology, and it is going to help us to create applications and deploy inside a container. So Kubernetes is a special tool that will help us to coordinate running multiple containers, not only one container. We want to run many containers. So that will, if something goes wrong, another container will keep running and the service will be still available. That is a high availability we are going to call. That is the main aim to get using with the Kubernetes. Build your tomorrow with Docker and Kubernetes. That is the main aim for this course. And you can stop me at any point of time and you can ask your questions, guys. And every session, what we are having in the Vybhava Technologies, we are going to record the course, record the session, and we'll share with you privately. And that is advantage. So about me, that is speaker having 20 plus years of experience in technical mentoring, and I'm into DevOps, DevSecOps, middleware, and automations with shell scripting, Python scripting. I also worked many clouds. I worked on OCI, I worked on AWS, I worked on GCP and Azure. So I'm also having a technical blogs on DevOps under blogspot.com, and Python specific programming learnings, whatever I did, that is Python orientation.blogspot.com. Middleware technology automated so many things in the services. I posted in the WLST by examples that is related to WebLogic. So that's about my short intro. And you want any questions on that before jumping into what is Docker? What kind of problem it is going to solve? All good?
No, sir. Yeah, all good.
Okay. So why we need Docker? So just I want to give a example over here, and you can see the problem. So applications, we are having portability problems. So what kind of portability? Developer is going to write the code and develop the code. He creates some Java program. He creates some Node.js or Python programs. Once they prepared that entire bundle of code, it is working fine in system. So he is happy and he said, I can push this code to next level. That is, it should go to the testing level. So developer is saying it is working good. So when it goes to the same code going to the next level, that is testing level, testers are going to have a different levels of testing, front end testing, back end testing, or user acceptance testing. And nowadays mobile testing also coming into that picture. So the developer sends the code, whatever he developed, that is not working for the testers. Testers systems are accessing the application, but they are not having something which is developer is having. So whatever he made the changes may not be available on the machine where testing team is trying to test. So this is a problem situation. The problem is due to portability. What developer system is having libraries or dependencies, what he is installed, doesn't know by the testing team, or they really don't want. They just want to test the application. That is a common requirement. Um, so we have infrastructure related issues. So this is also one of the common issue. We have developed a lot of um, virtual machines using the cloud, and also um, VMs using the different tools. Okay, so virtual machine can be created with the VMware, that can be created with the Oracle VirtualBox, that can be created with the KVM. So these are the different options we have. So virtual machines are not real machines, they are virtual. The name itself tells that. Okay, and when we are creating the virtual machine, we are telling that I want 4 GB RAM, 2 GB RAM, like that. You can create n number of machines on your system, how much space you have on your host machine. So there are two things, host machine and virtual machine. So there can be different tools, Oracle VirtualBox, VMware, KVM. So that depends on the host machines. If the host machine is Windows machine, or MacBook, or your Linux machine also. Okay, you can use any one of these tools. Okay, so once we have these tools, what we are going to get, we are getting virtual machines. When the problem is identified, developer is working and he's getting the work done with his system, same kind of system wanted to pack and move to the next testing team. That is what the idea for virtualization. So first level of trial, they want to try with the virtual machine and they started working with this solution. Okay, so virtual machines are starting multiple microservices architectures. They started initiated, but after that, they have their own troubles, slowness, and a lot of other things. We'll see that how it is different. So Docker is a containerization tool. It is a part of DevOps. Okay, so what we are learning, it's advanced DevOps tools. Um, Basic tools are GitLab, or GitHub, and your Jenkins CI/CD tools. Those are all comes under basic automation tools, basic DevOps tools. So Docker and Kubernetes comes under advanced tools. You need to understand the complete architecture about Docker and how that can be run in a production environment. That is a bigger challenge. Okay, so we try to understand this in the course, Docker and this Kubernetes, how they are going to integrate together to give more high availability, etc. Okay, so Docker is a containerization management tool, and it is used as a DevOps tool, and you can manage your software for isolated. Means one service is running in one container, it will not disturb with another container. One tester is testing, another tester doesn't know what is happening in another VM, another container. So that is what the specialty. And they are self-sufficient containers. Means in a container, there will be one particular service only running, one particular process. If you take the Linux processes, only one process will be running inside the container. That is a limitation we have in the Docker. That is the advantage we are going to get. Okay, which can be deployed and run in any environment. So this is the advantage. So the logic of Java initially started write once, run anywhere. That was a motto of the Java language, and the same ideology come into the Docker also. Similar kind of, but it is much more matured level, and agility is added to this one, and we are able to build and ship the Docker containers very easily when we are putting that application into container. That is the advantage. Okay, so what is a outcome, why we are saying this one, and we are just having a one solution already, why we are getting into this one. So we just seen the problem is with the if the system application is working, it works on my system is a developer saying, and tester is saying it is not working. So that is a problem, and the challenge is solved by two different solutions. Okay, one is virtualization, all clouds implemented with this virtualization. Containerization, what we are going to learn, that is super fast, high speed or rocket speed we are going to get with the containers. High level differences. So this could be one of the interview question also. What is the difference between virtualization versus containerization? Virtualization, it is going to take, if your first attribute we are going to take as a size, it is going to occupy on your host machine heavy size. Memory will be wasted unless until one virtual machine is started, another virtual machine cannot start. Okay, whereas containers, it doesn't take that much size. First time it is going to take some time to launch, but there is no wastage in the disk space, hard disk space. Immediately it is going to launch, and it is going to up and running, available the application or whatever you target inside the container. Boot time. So if you are going to launch one virtual machine, it might take 2 to 3 minutes max. Even in high speed laptops or high speed systems, you might get this boot time in minutes. When you compare with the containers runs in milliseconds. You never wait for any container at all. You just hit Docker run command. It will give the container up and running, and you can run web applications, you can run database services, you can run anything, load balancing, whatever the software you name it, and you will get the containers in the Docker. Integration. So if you're going to use the virtualization, you know already all cloud virtualization concepts are costly. You need to pay and then use the virtual boxes, virtual machines. AWS is costing differently, GCP costing differently, Azure is giving different pay and use. Whereas containers, it is simple, easy, and you can create n number of containers. There is no limit, there is no hardbound, and that is all depends on your hardware, of course. But the limitations are coming from uh, the size is very smaller if you compare with the virtual box. Container starts very quick, and there is no waiting time, and virtual machine is going to run with one own operating system, whereas containers are going to share. If you are going to run 10 containers, one container is running for the web application, let's say Java web application Tomcat, another application running for MySQL. Both can share one CentOS Linux operating system kernel. So that is a beauty of containerization. So sharing the host machine is there so that the upper layers, layer by layer, it is going to work, and the containers will be very easy to launch and start, create the image, and easy to work with them. As we always look for the packing and shipping, that is what the main advantage we are getting from the containers. Packing and shipping is much more heavy when you look in the virtual boxes. There are boxes which are available on Amazon, but Amazon only can get those on their platforms very quickly. But if you look at the containers, it is super fast, and without waiting, you are going to get that images creating the containers. Network level, uh, the isolation part, if you're going to use in the virtual machine, it is going to take the permissions, bridge network, host network. These are the different types of networks which we are going to see when you configure the virtualization or virtual box using Vagrant, using VirtualBox, or using VMware. These networks we need to configure, we need to look for them, and a lot of work around this network. Whereas containers, entire thing will be taken care by your Docker engine. Underneath it is working, and it is only takes the help when it is going to connect with the external systems gateway. Okay, so Docker host uses a single network, one network only it is going to use. All containers will use one private network. So there is no directly public access. It is going to be having one entry, and there will be complete monitoring abilities from the engine itself, Docker engine ability. And even when we go for the Kubernetes, there also we can have a different strategies for networking that will be super fast to compare with the virtualization virtual boxes. So these are the important differences which we can see between the virtualization and containers. Okay. Any questions? Santosh?
Yeah, no worries.
All good?
Yes, I'm still that confusing with the virtualization and containers.
Okay.
For example, VM is nothing but one server, right? VM you're talking about under virtualization.
Yeah. Yes, Santosh.
So, for example, if we take Linux like VM, there we install, for example, two Apaches. In one server, we install two Apaches, right?
Yeah.
For example.
Mhm.
So, if we go with like EC2 machine, that is also VM, right? EC2 machine is nothing but VM.
Yeah.
So there we like create two containers. So two container in the means one container is one Apache and second container is second Apache, right?
Yeah.
So what is the difference between these two? In virtualization, we have two Apaches, and in EC2 machine, we creating containers. There are also two Apaches in the same like machine. So what is the benefit here?
Benefit, two important benefits I can tell you. That is, as I explained in the previous slide also. One is disk space. First,
Okay.
if you are going to take the EC2 instance, two EC2 instances, two Apache instances you are creating, right? So two different disks and memory required for them. Where if you go for the containers, the platform operating system itself, it is shareable, and you don't need to have a two different disks. Only one disk is enough to run the two containers. Okay. On upper layer, you're going to have this Apache containers. So each container will have its own IP address. Underneath, there is only one physical network will be there. Okay. Maybe it is not completely clear, but yeah. So two things we are going to get the benefit with the containers. One is network. Second one is disk space. These two are completely isolated from the host machine, and you will be economically less consuming from the containers. Whereas in virtualization, it takes longer time and it will run slow. These are the differences.
One more thing, sir. Yeah, if we instead of going with this third-party Docker, can we go with cloud containers like ECS or from Azure?
Yeah, they
But
are
if we go
all
with the Docker, who will give the support? Like if we have any issue, yeah,
yeah,
definitely we'll get issues. That is yeah, in the
correct.
real time. Yes.
Yeah, correct, Santosh. Yeah, so most of the common issue is Docker. First, they publish the open source software, so anyone can take that one and implement. So what they did, AWS, they started ECR and EC container architectures from them, and they created flexibility, and some of them are restricted to that cloud only it will work. And
Okay.
support, definitely they will give. DevOps, AWS DevOps support they are going to provide. If you have
Yes.
something goes wrong, and you will get the help from the AWS support team.
Right.
Yeah.
Right.
So Docker, if you learn the commonality, what we are going to do with the normal Docker, and same thing you can do with the AWS containers also. And you can do the same thing with the Azure containers also. Advantage of learning core Docker is, this is the advantage. You can first learn this core ideology, and you can run on any platform, any cloud.
Okay. Okay.
Yeah. Okay, so here I'm just giving best solution of the containerization, what we are going to get benefited. If you look at the Linux operating system or any operating system, if you take Windows system or Red Hat or Ubuntu, any system, how they are going to compartmentalize. So there are three parts. One is operating system. So when you are going to take the operating system, common thing is Linux kernel. So Linux, everyone knows it's open source operating system, right? So this Linux operating system, we are going to have a same Linux operating system from Windows 10 specific latest versions. It is supporting emulated Linux kernels. Okay, so these three, if you compare, even if you go for the MacBook also, that is also Linux. So they main common things, you user, whenever you connect, you want to launch your Word document or Excel sheet in Windows system, they're all run in user space. Okay, when you run in a Red Hat Ubuntu, you are going to run some servers, like as we discussed earlier, right? So web application, you want to run Spring Boot application, or you can go for Tomcat server that will be running on a platform where you are having a Linux kernel. Okay, so the Linux kernel is common, user space is common. These two things are required. That is what common things are kept in one copy only in the containerization. That is the best solution it is providing. And each user, whenever they are going to try to connect, they want to connect to Ubuntu, they will get Ubuntu flavor in their container. Who want to connect to the Red Hat, they will get Red Hat commands will be executed, accessible in the Red Hat container. Okay, so that is where the best solution coming from the containerization. One important thing from the containers, Docker containers, are they are supporting, they are easy to handle microservices, and you can have SDLC quicker or easy to market and provide it super fast to the customer client who are waiting for it. Okay, so that is the best solution we are getting from the containerization. You can run this containers, n number of containers you can run, and each container is going to run with a microservice. The service can be anything, which is going to have a one endpoint. It is going to have an IP address and port number. All right. So when we are going to use this Docker, what we are going to have? Docker is going to have images. From the image, it is going to create the container. So whenever you want to use Docker image, actual image, first time when we are going to create, it is going to stored in your Docker engine, and it is going to call it as a Docker repository. So whenever you want these containers created, the layers which are required from one particular image, that will be remain there only. Only the container 1, container 2, container 3 comes into your requirement. Then all containers feel like every container is having 1 GB, but actually it is a just layer where we can read, write. Okay, that upper layer which is accessing container, that is layer, and that is only newly created. Remaining everything will be same and fixed what is there in the disk. Okay, so this is a strategy it is using, and the kernel and what we are just seeing, Linux kernel, the bottom layer user space will be the same for all type of images. Okay, what we are going to learn in this session, we are going to use, actually, I thought of sharing my Docker playground, but I think I'm not able to access that at the moment. But anyway, what is a overall course we are going to have? Uh, who can do this course? First thing, anybody have this question? Who can do Docker Kubernetes? Everyone can understand, or you have some questions related to that?
Yeah,
Sai
hello,
Krishna.
sir. Actually, I'm not into DevOps. Actually, I do not know anything related to Jenkins or
There is
Ansible,
no
whatever
link.
you call.
There is no link with the Jenkins and Ansible, Sai Krishna. They are basic tools, and every tool is independent. You don't need to have a dependency. Docker is completely isolated from the beginning. You can start working. Only requirement is you should know Linux commands. If you don't know, even then you can learn while working with me and learning.
Yeah, actually, I don't know Linux commands much, sir. Actually,
Much is
so
not required. At least what I'm saying, you can type, that is enough.
yeah, sure. So
Uh,
there is no other prerequisite
No other
really needed.
prerequisite. Yeah. So you should
And
aware of what is software, what is how you are accessing web applications. That is a basic requirement. If you know, then that is enough. Because we are starting from the scratch everything. You don't need to worry about it.
and I just had a conversation with you in WhatsApp, right?
Mhm.
So post this course, can we go ahead and do this Kubernetes administration,
Certification. Yeah.
yeah,
CKA.
certification, right? Yeah.
Even Docker is also having certification. Docker certification is called a DCA. It is also very worth and doing. Two important things when we are going to work for a project, it is completely different. When you work in a certification target, that is also completely different. But in these two areas, Docker and Kubernetes, there are some environments, playgrounds are available, and you need to work with the quizzes, practice more on that one, then you can do
Okay.
that. It's not a problem.
And also, if you want to shift our career to Kubernetes and Docker, is it fine, right? I mean,
Yeah,
like
yeah, definitely it is
these
fine.
these
What
two
you are doing
technologies
right
will
now,
help.
not only
So
this, you
I'm
should do three things, Docker, Kubernetes, and Ansible. Three things should be aware, though, so that you can do automations along with the DevOps tools.
okay. Presently, I'm working in SSRS, sir. Actually,
What is that? SSRS means?
reporting tools. Reporting
Reporting tool.
tools.
Okay.
Yeah.
Basically, thing is, anyone can change their career path to any other. That is, there is no restrictions. There is no hard and fast rules also in IT, especially. Only enthusiasm is required.
Okay. So apart from this, we need to know about Ansible. You're saying.
Yeah, I'll go with the same sequence. First Docker, Kubernetes, and then Ansible.
Thank you.
Yeah. So Docker, yeah. So in our course, we are going to cover all the concept related to Docker, and then Docker engine architecture. That is a basic requirement to understand how it is working, master slave configurations, etc. Docker deployment topologies, how the application will be sit into the containers, how that can be run, how we can increase the number of containers. That is, we are going to call it as scalability. And then after scaling, you should have an idea about how we can make master slave setting with the Kubernetes. So Kubernetes concept, that is basic idea comes from the pod and where we can run the containers inside the pods. Kubernetes architecture, that we will try to understand each and every part, how that is constructed better than any other tools compared with the deployment strategies. We try to understand that one in the course. And Kubernetes is having its own CI/CD deployment process, where CI/CD word we heard along with the Jenkins pipeline always. So here we can also work with the Kubernetes tools, separate tools also there, and we can do pipeline deployments with the Kubernetes. Okay, so that is the overall idea of what we're going to do with the course Docker and Kubernetes. Okay, when we are working on the Docker, you should what we have to keep in mind. So first thing is SSH protocol idea you should have, and how we can connect to a Linux machine. Generally, we connect with the PuTTY and CLA commands, as I mentioned, Linux commands you should have aware. If you don't, then we will try to work out on that. If you want to work on the GCP AWS, then you need this credit card registrations required. But if you are not going to work on AWS or GCP, there is a solution called one virtual box you can create on your system, and inside that you can install Docker. Inside that you can install Kubernetes. We can do practice on that one and work it. Okay, so you should have a good internet speed so that we can access the Docker hub where we have hundreds, thousands of images available there. Okay, software images, microservices which are configured, created, ready to use. You can have a laptop that is more than 8 GB RAM, then you can set up your own lab on your laptop. That is the ability you can do. Better to have good USB earphones so that we can talk clearly. What I'm using, that is a USB earphones. Okay, so Docker on a high level, what I'm going to cover in the course in detail is monolithic and containerization, how it is going to work, and how we can build the Docker images, Docker containers, how we can create containers and connect with each other, communicate between the containers. All those things we'll try to understand clearly. And building the image is a most important thing that we can write into a file that is called Docker file. So this is one of the critical point most of the interviewers are looking for. Do you know Docker file, how you can write? So we will try to do practice on this one and build our own Docker images. Okay. And we can also work with the volume storage. So Docker requires the storage, and we can create, attach, detach, all those things we can do, just like how we can do with the AWS regularly. So similar kind of setups we can do with the Docker also. Network, we can create isolated networks. One project will be working for the development and the network will be created for development. Same production, you need bigger network, more number of systems you want to integrate, then different network we want to create. That is also possible. So we can go ahead and work on such kind of simulated setups. Docker registry, most commonly we are going to have a one question related to this one in the interview, that is, what is the difference between the private registry and public registry? Docker Hub is a public Docker images where you can store, and private, that is any company who want to create their own containerization architecture they are going to maintain inside their in-house registry. So how we can make, we'll try to build that one in our course. Docker Compose, when you want to run launch at a one hit, 3 or 4 containers, then we compose one after the other. So why one after the other? There is a dependency. Sometimes you're going to start the database. After that, you want to launch the web application. Then you want to launch the load balancer or proxy service. So these are the common requirements. You can put all these 3 containers and launch it using the Docker Compose. When we learn so many things about the Docker and what is the best thing, what is the worst thing, we should know. So best practices also we try to understand and work on it. Orchestration, there are 2 options we have for the Docker containers. One is Docker Swarm, second one is Kubernetes. So we try to understand how Swarm works and then we'll go for the Kubernetes. Okay, so Docker architecture in a high level, but I think it is another 2 minutes. Quickly, how we are going to have the engine. Docker engine is running in the middle. That is, we're going to call it as a Docker server. So it is running in a background. That's why it is called Docker daemon, Docker D as a file. And then how this is going to work, communicate between our commands, what we want. Okay, so the commands will be taken by the Docker client CLI. And what it is going to help us, so it is going to help us to create Docker network. It manages, it creates, deletes, all those things we can do with the Docker CLI. All the commands whatever we are giving, the carry forward or mediator will be REST API. So whenever you start running Docker engine, the communication always happens with the REST API. REST means HTTP protocol in between your Docker server and your client, the command line. And when you're working on this Docker, we are going to work on the images, volumes, containers. These are all different types of objects, Docker objects, which we are going to access from the Docker client. Okay, so we can work on these different objects, and that is what our learning objective. So when we are working on the microservices, this setup is required under Docker server on your server. Any questions? Good. Okay. So when we are working on the Docker registry, Docker is going to have some images, and there could be Ubuntu image, there could be CentOS, there could be some other. So you can pull that image and put into your Docker host machine, and these images will be actually creates your containers. So these containers are going to have a different space. Images will be in a different space. So there is completely isolated, but memory space totally in one common location. So all these are managed by Docker daemon, Docker server. So whenever you want to give the command like a Docker client command, Docker build, Docker pull, Docker run, these are the different commands. 1 or 2 we are seeing here, but there are hundreds of Docker related sub commands will be there. Docker is a command and sub command is build, pull, run, etc. Docker. Okay, so Docker, how it is going to work with the build process, or when you work on the Docker files. Docker file we are going to compose. So we are going to write some image related stuff here, and that is going to be executed with the Docker build command. Build will create the Docker image. Docker run, from this image you can create hundreds of containers. Okay, so this is a ideology: build, ship, and run. So when we discuss about the Java, we talked about that write once, run anywhere. Docker build is going to use the file, that is Docker file. This build will be used once you write, run anywhere, any system, anywhere in the world where Docker engine is there, you can run it. Okay, that is the ability where we can get this one. Any questions on this build and Docker process? Don't worry much about how that is going to happen, but we will learn about each one. And okay, so let me just try on my browser. If possible, I'm able to connect to that or not. Uh, Generally, when you search for the Docker playground, then you can get this playground freely available, and you can just try to log in GitHub or Docker Hub. So any one of the signing is required. I think I don't have this access at the moment because of network access problems. All right, Docker, whenever you see Docker is having one of the list of DevOps tool. So all DevOps tools are having documentation standardized, and Docker is also following the same. Docker.io is a standard documentation. If you go for the Jenkins.io will be there, the documentation. Kubernetes.io, or any cloud native foundation tool that is always follows .io as a documentation where you can have all the details. So the main advantage, develop fast and run anywhere. This is what the ideology of Docker. Okay, so it is keep growing super fast, and there are millions of users here. Millions of projects are so running applications 7M plus. Okay, monthly images are pulling 20 billion. So this is pulled from the Docker Hub. So that is a specialty. All right, so that is about Docker documentation. You can go through it and understand how that is keep growing. And yeah, so I think demo, maybe we can work practically in one of our systems and then see. At the moment, I'm just skipping this demo part. Yeah, so I will stop here. Any questions that I can take, discussions, anything related to Docker and Kubernetes? Sanjay, Dilip.
Actually, is it a weekend batch or is like daily we'll be connecting, sir?
We'll be connecting Monday to Friday evening 8 p.m. And
So
there could be off on Thursday occasionally.
yeah, 8 to 9:30 kind of thing, or
Yeah, 1.5 hour.
sure, sir.
Okay,
How many days it will go? Like 45 sessions, you said,
It's
right?
45 sessions, I told you.
Okay. Thank you.
Krishna,
this is
any
Vimlan.
question? Yeah, Vimlan.
Yeah. Hey, I have a question. Like, so by the end of this course, so what can I say actually?
You
I
can,
learned the basics.
yeah,
Yeah, I have learned. I can say, can I say I have learned the basics, or will it be an advanced one, or what
advanced
sort of
one. You
thing?
can do two things, Vimlan.
Yeah.
One is if you already aware of it, you will be mastering that. And second thing is everything we are doing practically, and I am not doing
Mhm.
anything from my side. You will be doing everything. So every participant should do the practical. That is the most important thing. And
Mhm.
we will be having certification questions also. Practically we are trying to do the experiments and try to
Mhm.
solve the problems. So real-time problem simulated. If you see the previous other questions, they are going to have MCQs, so multiple choice were there. Now this Kubernetes Docker, they are scenario based. They give a situation and you need to solve the problem. So that is
Mhm.
what
Mhm.
we'll have in the certification exams. Similar kind of setup we are going to do in our lab exams. Practice.
Oh, okay.
Yeah.
That would be great. So by the since I have been listening to you, we have seen about what we are going to learn on Docker. So
Correct.
likewise, exactly what we are going to learn on Kubernetes, because I do not have much background of what this Kubernetes is and uh, what actually is covered in Kubernetes. So when we say Kubernetes, actually what we are going to cover actually.
Yeah. Actually, I put the content, but in between, I have a lot of monolithic and microservices stuff. So I just stopped there. Yeah. So in the Kubernetes, we are going to have complete 22 plus sessions about Kubernetes, and we'll try to understand complete orchestration and all
Mm-hmm.
the concepts related to pod and network and volumes in that Kubernetes. After that, you will be setting up master slave architecture in the Kubernetes also. We'll try to work with the different objects which are there in the Kubernetes deployment services, namespaces, network, storage, persistent storage. These are the things we are going to work. And how do we allocate these particular deployments into different environments like development or production or non-production. These are all we are going to define with the different labels and selectors, and we try to work with that examples. That is covers almost all CK related the certificate Kubernetes certified Kubernetes administrator topics.
Oh, okay, yeah. This is what actually I've been looking at.
Yeah.
So, like what we are going to cover on Kubernetes. Okay.
Yeah, so most of the security related stuff we are going to cover, and configuration management we are going to store with the config maps in the Kubernetes, and as I told you, storage, that is the volumes we are going to define in the Kubernetes. Networks, actually it is coming slowly, but yeah, these are all things we are going to cover with Kubernetes. Scaling part, auto scaling, auto healing, all these things we will do practically and see how it works.
Okay.
Monitoring also we'll try to see on Kubernetes.
Sure.
Yeah. Any other questions, guys?
Not from
So
my side.
this
I'm good.
using this deployment using YAML files and all will be covering, right?
Yeah, and, all Kubernetes objects work with YAML only. You will be learning mastering in the YAML. So there are two different things YAML is going to help. So when you work in Docker Compose, there onwards you will see YAML. Docker Swarm, that is also orchestration tool. There also you can see YAML. Coming to the Kubernetes, again, every object like pod, service, deployment, network, storage, everything is YAML based. We'll try to write that one and try to run it. Any other questions, guys?
So we'll be starting this batch from Monday, right, sir?
Yeah, Monday. Everyone comfortable? So right now, just how to see the documentation I just shown you, right? So docker.io. Similarly, kubernetes.io also you can check. And there are a lot of implementations and deployments are going on with the Kubernetes. A lot of scope for the job. And even in LinkedIn also, you can just search Docker and you can see how many jobs are there. Kubernetes, you can see how many jobs are there. So that is what the ability containerization or microservices ability, which you can get very easily into the DevOps related jobs. There are a lot of scope and there is a lot of requirements also. Very less resources with the skilled people. Um, I'm just quickly running. Okay, so any more questions? All good. Okay, so see you guys on Monday. Hope you will connect on Monday. And who are interested, please call 961-871-5457. Any questions before winding up today's session?
No, all good.
All
Thanks
good.
for the session.
Okay, thank you guys. Bye bye. Have a nice
Yeah,
evening.
thank you.
Bye.
Thanks, sir.